Okay guys, so this is the second page of our notes on geometric series. So the back side of the sheet that we did on Monday. So we're continuing along our merry way. Now we're actually going to have a situation where there's context to our geometric series. And this one is very relevant, right? Because it involves money. So let's look at this scenario. A family invests $2,500 at the beginning of every year and earns 8% interest compounded annually. So guys, this is different than what we were doing before with compound interest, because this time, before what we were looking at is one investment that grew, right, each year. We didn't add new money in every year. So this is actually a much more realistic scenario. Like when you put money away every year in your retirement account, or you add money every single year. So as opposed to just one chunk of money growing and compounding over a certain number of years, now what we're doing is adding the same amount of money each year. So this kind of steps it out for you, right? So if I want to figure out how much money am I going to have after 18 years, well, after the first year, right, I would have my $2,500 plus, right, the 8% added on. Now let's think the second year, I still have my first $2,500, but now it's had 2 years to grow. And then in red, I have my new $2,500 that has had 1 year to grow. Right, I like this color coordination here. Then in my third year, right, now I have a new $2,500 that's been growing for 1 year. My second contribution after the second year is now 2 years old, and then my first one has now had 3 years to grow. So I'm hoping you guys see how this can make us a lot of money, and this is why people say save early, right? So I could keep writing this out 18 times, but that's kind of burdensome. So let's think of this as a formula, a geometric series formula, right? So here, what I'm doing is I'm multiplying by 1.08 every single year, right? And that we know as R. So what I've got for my geometric series is this. So this scenario right here, we're only doing 4 years. So if I wanted to map out this scenario in a geometric series, I would say, okay, for 4 years, I'm going to contribute $2,500 and it's going to grow 8% for K years, right? So here I've got, right, it's my K equals 1 to 4, so it's going to be growing for 4 years. Now, what they asked us in the first part is, what if it's growing for 18 years? So let's now look at what if we're going to have 18 years. So here is our 18 years, right? We still have the same formula, 2,500 times 1.08 to the K, but this time K is going to go from 1 to 18, right? And if you remember from the first side of this notes, we have our formula here. So remember, A1, guys, is where K equals 1. K equals 1. So if I plug in K equals 1, I'm going to get 2,500 times 1.08 to the first, which is going to give me 2,700. Notice what's not here. It doesn't say K minus 1. That's the thing that's different here, right? So we're starting where K, I could, if I want, start with a different K and then write K minus 1. But here, after the first year, this is the end of the first year, right? And I can see up here that R is 1.08. So I'm going to put 1.08 and we're saving for 18 years, right? And we know R is 1.08. So if I do this in my calculator, I can see that by putting $2,500 in for 18 years at 8%, which is pretty nice, I would end up with $101,000-ish, right? So it's really, really worth it to save money. Okay, let's look at a different scenario. Okay, this is the same type of thing. A worker invests, oh, what did Mr. Foster say here? Oh, he calculated A1. Sorry, guys. I didn't realize he did that. Okay, a worker invests $1,200 at the beginning of every year and earns 6% interest compounded annually. How much will the investment be worth after 25 years? So guys, this is the exact same problem that we did before, but with different numbers. So we're finding S25. So let's write our formula for S25. So that means K is going to go from 1 to 25, and we're putting $1,200 in, and it's growing at 6%, right? So here we've got, again, we got to get A1 by plugging in K equals 1. So if I get A1, 1,200 times 1.06, my A1 is equal to 1272, right? So let's substitute in, oh, I shouldn't have spoiler alerted it, but we're going to put A1 right here, which is 1272, and we can see that R is 1.06, right? And I'm saving for 25 years. That's a long time. And then my R on the bottom is also 1.06. So you can see, guys, just by putting $1,200 away every year, that's not that much. If it's growing at 6%, right, I'm going to end up with close to $70,000 at the end of 25 years. So anyway, that is our lesson for today. And now you guys can work on the geometric series homework. I will see you guys Friday.